Okay, Assalamualaikum warahmatullahi wabarakatuh. So today we are going to learn about a new chapter for Mathematics Form 4, KSSM. So you guys are very lucky to be in KSSM because you are learning far ahead from others, okay? So in chapter 1, it's a quadratic function and equation in one variable. So I'm going to explain to you part by part. So we start with part 1 first. Identify and describe the characteristic of quadratic expression in one variable. Okay. So I got this from slide from Madam Wong SM. You might want to see it in YouTube. Okay. So the first thing first is quadratic expression. I know that some of you I already taught you on when you were in Form 1 and Form 2. Okay, so we already discussed what quadratic expression is. So let's see the example in diagram 1. Have you ever sketched the movement of a ball kicked by a football player? So if you can see here, that's a footballer kicking a ball, and somehow the ball is going upstairs, going up. Okay. So from the ball to the leg, you can see that it's making a curve, right? You haven't noticed this until you've seen this, right? Okay, so that is the kind of shapes that you'll see. Okay, so we call that shape as parabola. Okay, the shape of this movement is a parabola. Do you know that this parabola has its own equation? So every function, every quadratic expression, every function have its own equation. Okay, in this case, the movement of the ball kicked by this football player. Okay, so actually quadratic expression in one variable is when in one variable means the expression whereby the highest power for the variable is 2. When you see quadratic means that the power must be 2. Power must be 2. Okay, the highest power must be 2. If the power is 1, then it cannot be quadratic. Okay, what is the difference between quadratic expression and quadratic function? This is simple. Quadratic expression is only an expression, okay? Meaning that 2x squared plus x plus 3 or or negative 3x plus square plus 1, okay, x 6x square. So this is quadratic expression. So what is the difference between quadratic expression and quadratic function? Easy. For quadratic function, the difference is that this is expression. You got 3 terms, right? Like this, okay? 3 terms for this, 2 terms for this one, and 1 term for this one. For quadratic function, the difference is just it has equals to 0. Okay, so that is the difference between expression and quadratic function. Okay, alright. Okay, so the general form of a quadratic expression is this one. When the question said about the quadratic expression in general form, you must have x squared, you must have x, and you must have constant. Okay, so a cannot be 0. Why a cannot be 0? I give you an example. A cannot be 0. If I have 5x squared plus 2x plus 1, so this is a quadratic expression. But what if my a is 0? 0x squared plus 2x plus 1. Is it going to be a quadratic expression? The answer will be no. Why? Because 0 is A. The coefficient for, this is what we call as coefficient. Per kali in bahasa Melayu. Coefficient atau per kali. Okay. Per kali for x square. Coefficient for x square. Coefficient for x is B. Coefficient for C, it's C, constant. Okay. So you cannot make A to be 0 because when a is equals to 0, so 0 times with x squared, there will be 0. So it will be 2x plus 1, or this is actually 2x plus 1, where this is not a quadratic expression. Okay? So as easy as that. Remember, a quadratic expression is in one variable. One variable means satu pemboleh ubah, or one unknown. One variable or one unknown is the same. Is an expression whereby the highest power for the variable is 2. Now, let's look at the next slide. Now, let's determine whether each of the following expression is a quadratic expression in one variable. Okay, this is easy. Remember what I told you? Quadratic expression. Quadratic means the highest power must be 2. Okay? In one variable means that if it's use x, then the whole equation or whole expression will use x as well. Only x, only one variable is appeared. So let's look at this. Determine whether each of the following expression is a quadratic expression in one variable. If not, justify your answer. Now, we tick 2 column, one quadratic expression in one variable, and another one is not a quadratic expression in one variable. Okay, what about this one? Is it a quadratic expression? Let's see. The answer is no, it's not. Why? Because the highest power of the variable is 3. Now next one, this one, 3x squared plus 6. Is it a quadratic expression in one variable? The answer is yes. Okay, it's followed the general equation where it is ax squared plus bx plus c. So you got x squared, but you don't have bx, it's okay, as long as the highest power is 2. Okay, next one, 3x squared plus 6y. It is not a quadratic expression in one variable. Why? Because there are 2 variables there, right? Which is x and y. Okay, the next one is 1 over 3x squared minus 2x. It's a quadratic expression in one variable. It's followed the general equation, general form. So this one. Okay, why 3x squared plus 1 over 3x squared is not a quadratic expression in one variable? Because one of the power is not a whole number. Okay, you see here, if I take this 3x squared, it's actually 1 over 3x power of negative 2. Okay, we cannot, we should not have any other power except for power of 2 or power of 1. Okay, so for this one, this is not a quadratic expression in one variable because the power is not a whole number. The power must be 2 or 1. Okay, right. The next one is 1 over 3x squared. This is a quadratic expression in one variable. Okay, this one, let's look at the A, B and C. Okay, so the quadratic form that I mentioned just now is ax squared plus bx plus c. Okay, now you have to determine, this is the general form. General form of a quadratic expression. Okay, so you have ax squared plus bx plus c. Okay, now this is the quadratic expression. Now you have to compare it with the general form. So if you can see here, 3 is the coefficient for x squared, negative 4 is the coefficient for x, and 5 is the constant. So we can see that our A is 3, our B is negative 4, and our C is 5. Okay, as easy as that. Okay, what about B? Okay, what about B? So for B is A is actually negative 1 over 3, B is negative 2, and C is 8. Okay, what about C? Okay, what do you see there? Do you have B? So you don't have B, so you see that your B is equals to 0. And your C is 7 and your A is negative 1. And what about question D? You see that here first, you have to expand it first. Okay, so when you expand, you get 3k square minus 5k. So your A is actually 3, your B is negative 5, but there's no C, there's no constant there, so C is equal to 0. Easy, right? Okay. So we have already covered part 1. So let's see part 2. Okay. So for part 2, we have to recognize quadratic function as many to one relation, hence describe the characteristic of quadratic function. Okay. Just now what I told you, quadratic function is when it is equals to 0. Okay? So there you go. A quadratic expression is written in the form of ax squared plus bx plus c, whereas a quadratic function is written in the form of fx. So you got fx there, so meaning that this is the function fx. Fx means this is the function. You can put it as equals to 0, quadratic equation. So quadratic function is when it fx, ax squared plus bx plus c. Quadratic equation is when you see that it is equals to 0. Okay? So, next one. To recognize quadratic function as many to one relation. Okay? If you have textbook, you can turn to page 6. Okay? So, if I have a straight line and I make a straight line there, and then what you see here, the straight line cut 2 points here. One here and one here. Okay? What is the number of intersection? So there are 2 numbers of intersection. So what is the point of intersection? You have to read it yourself. Okay? So one is negative 1, 4. And another one is 4, 4. Okay. So we can see that if you see here, they are sharing the same fx. Okay, so we say that negative 1 is mapped to 4. Negative 1 and 4 is mapped to fx. So negative 1, 4 as well. Okay, so negative 1 is mapped to 4, or the value for fx is 4, and 4 also is mapped, or it is equals to 4. Okay, the type of relation of a quadratic function, this is what we call as many to one relation. Okay? Okay. Next one. If I have another line and I draw it on the graph, you can see that there's 2 points of intersection. So you have to read it. What is the point of intersection for the first one? So this is the first one. And this is the second one. Okay, so the first one is 0, 1. And the second one is 4, 1. Okay, so using the function, okay, by using the function that you have learned this before, so you can see that your x, what is the value for your x? So you got 2 value of x. One is 0, one is 4. But the fx is 1. Okay, so we can say that 0 is mapped to 1 and 4 also mapped to 1. So the type of relation of a quadratic function is a many to one relation. Many, got many here, and it maps to only 1 here, right, for fx. Okay, so describe the, let's see how can we describe the characteristic of quadratic function. If a is greater than 0, then you can see a smiley graph. Okay, if you see that the a is less than 0, then you can see a sad graph. There are only 2 shapes of the graph. The value of a determines the shape of the graph. So for the first one, a, we have function fx equals to 1 over 3x squared minus 4x plus 4. What is the value of a? So the value of A is 1 over 3. So what is the shape of the graph? So you can see that the shape of the graph is smiley graph, like that. Okay, so it's supposed to be smiley graph. Okay, what is the maximum or minimum point of coordinates? So if it's smiley, so it have a minimum point and coordinates. Okay, so you know that this is the minimum point. So in maths, you already know how to find the minimum and maximum point. You learn this later on. So for mathematics, you just need to draw and then you determine what is the maximum and minimum point of coordinate. So from the graph here, you can see that the minimum point of the coordinates is 6, negative 8. Okay, so what is the axis of symmetry? Do you see that this graph is centered and it has axis of symmetry, where the axis of symmetry is in the middle of this one. Okay, so we can say that the axis of symmetry depending on the minimum or maximum point. Okay, for x of x. Okay, so we see that 6 is the x is equals to 6. That is the axis of symmetry. So we see that the axis of symmetry is equals to x equals to 6. Okay, what about this one? So we have b, the function b. What is the a? A is negative 1 over 3. So the shape of graph is Z graph. Okay, so if it's a maximum point, then it will be sad graph. So you will have maximum point as well. So this is the maximum point. It's like we are climbing up the we are climbing up and then the mountain, and then you find where you are at the maximum point of the mountain. Okay, so the maximum point we can see here from the graph, the maximum point is negative 6, 16. So can you determine the axis of symmetry? Okay, as I mentioned earlier, the axis of symmetry, it depends on the maximum or minimum point that is parallel to the y-axis, or you can take it as x. Okay, so the axis of symmetry is equal to x equals to negative 6. Okay, the equation of axis of symmetry for a quadratic function is, okay, there you go. You got another formula here, where to find the axis of symmetry you can use the formula of negative b over 2a. Now I show you, I prove it to you that we are going to get 6. Okay, so you have just now you have your a. Let's do the first one. You have your a is 1 over 3 and your b is negative 4. A is 1 over 3. Then let's substitute into the formula. So negative b is negative 4 over 2. A is 1 over 3. So this is like 4 divide with 2 over 3, or we can simplify it to be 4 times 3 over 2. Simplify 2 and then you got 6. So your x is equals to 6. As easy as that. Okay, jot down the formula for finding the equation of axis symmetry, which is x equals to negative b over 2a. Okay, now okay, so let's look at, okay, I think that's all for today. So we end until chapter 2, part 2, and then after that I'm going to continue in the next lesson for part 3 of quadratic function and equation in one variable. Thank you very much.